So welcome all for this fifth webinar on the Galaxy workflows around COVID. And today we will focus on the infrastructure side and give you a glimpse behind the scenes how we've established this global open infrastructure and made it work. So this global aspect is also reflected in the speakers that we have today, with not only people from Europe, but also Simon from Australia and Nate from the US, with special thanks for Simon, as this is in the middle of the night for him. So in the last months, we've been presenting the different workflows that have been made available in Galaxy around the genomics part, evolution, and the cheminformatics. And what we tried to do is provide solutions for researchers that want to analyze this COVID data. Researchers around the world want to analyze COVID data from national initiatives and compare these to the international data that is available. And these are from usually quite specific communities that might not have been in contact with this type of data before. So they don't necessarily have a deep computer science skills to analyze all this big data. And moreover, in all these diverse analysis that we've presented, there's different needs depending on the type of analysis that you want to do. Genomics data is per sample relatively small, but there's typically a lot of samples that needs to be analyzed in parallel. If you then compare that to the molecular docking, there we actually needed GPUs to make this efficient and to actually run this analysis at scale. And for some other aspects, we really needed interactive analysis where it's just not submitting a job and waiting for the result, but the user needs to be able to interactively change parameters or view visualizations. So all of these things needs very specific infrastructures. And we wanted to make this available in one common environment. Of course, all of these workflows require expert knowledge in virology and all the aspects that come with it. So the big question here is, how can we make all of this available to researchers that they can access and use these resources? And of course, when analyzing COVID data in such a pandemic, there is a sense of urgency. We do not have time to build an infrastructure from scratch. We don't want to spend weeks and weeks preparing this. We want to have this really fast available. And this needs to be globally, because this is a global pandemic, so it's not located in one specific country or one specific region. We really need a solution that covers the whole globe. So we have been building on tried and tested and proven technologies and infrastructures that are there. ELIXIR has been an important part in this, but also the Galaxy project, obviously, in this context. And this allowed us to do a global rollout of these workflows in a matter of a few weeks. And this is really a unique achievement, and I really want to thank all the people involved, because this has been a fantastic collaboration to get this working. And this collaboration has been combining a lot of different disciplines, expertise, infrastructure, and most importantly, people. One important aspect, obviously, is the Galaxy project. So Galaxy as the open platform to do reproducible analysis. If you want to know more, you can look at the first webinar or go to galaxyproject.org. And of course, another part is that we wanted to be able to distribute this analysis across different compute resources. Typically, the analysis that need to happen here, the scale at what it needs to be done, and the user base, so the researchers doing these analysis, aren't a very good fit for the typical HPC infrastructures. The users don't have enough knowledge, and the scale of the analysis is not of the size of millions of CPU hours, for example. There are many national clouds that have been established across the world to kind of tackle these specific problems, but they all have different hardware, different configurations, different software stacks, so we need to find solutions for that. And typically, access is restricted to the local researchers. Therefore, we have different solutions depending on the use cases. And in some cases, there is a local infrastructure. In other cases, they need to rely on centralized infrastructures such as usegalaxy.org or .eu. Some cases, data is sensitive, so they need to do everything local. And some users have more experience in computer science and have more skills in that. So also that depends or kind of dictates how they can deploy certain solutions. Central around this is Pulsar, which is a program that has been developed within Galaxy to distribute the jobs of a Galaxy server across different compute resources, and we will go into more detail how we've deployed this both within Galaxy and across the cloud resources to make this possible. You can find more information on the GitHub link at the bottom. And so today we will present you different ways of how we've deployed Galaxy to cover these different aspects. We will start with the usegalaxy.star network, where we try to make the same workflows and the same data, the same reference data available across different Galaxy instances across the globe. We will also present the usegalaxy.eu Pulsar network, where from the centralized server we can submit jobs in different compute clusters, again across the globe. Then we will focus on cloud deployments through the Laniakea service developed in Italy, where different Galaxy flavors can be spun up at demand. And we also will briefly touch upon the local deployments through Docker, where anyone can, on their local infrastructure or even local computer, get these workflows up and running in a very brief time period. Starting with usegalaxy.star, this is a collaboration that has been ongoing for a while now between public Galaxy instances across the globe, and the idea is that we want to align on a core set of tools, workflows, reference data, with the goal that we can have workflows that run in all of these instances seamlessly and that produce the exact same result regardless of where you want to analyze this. So this is really going to the heart of reproducible analysis across Galaxy instances. And with that, I will give the word to Nate, who will talk about usegalaxy.org.
Yeah, thank you, Frederik. So a bit about usegalaxy.org. It's a public Galaxy server, really the first public Galaxy server that's been operating since 2006. For a number of years, it was run out of Penn State, but eventually moved and grew at the Texas Advanced Computing Center TAC, using resources provided by the Cyverse project and some NSF grants. So right now, it's essentially a collection of VMs that we use to run the Galaxy server, and then a small cluster of 16 bare metal nodes, and then a considerable amount of storage provided by DDN. So our users are granted 250 gigs of storage, and that can be increased up to about a terabyte for specific projects in temporary allocations. It just has to be requested with a description and a use case for that. And then you receive essentially a different amount of compute depending on the types of analysis that you perform. So some statistics, we have about 185,000 users with about 2,500 new signing up per month. We run about 250,000 jobs per month, or about 225,000 CPU hours a month. And we're currently storing about 3.5 petabytes of user data. So if you give me the next slide, please. Thanks. And so we were in this environment of resources provided by TAC and Cyverse, and the NSF put together this extreme science engineering and engineering discovery environment called Exceed, which pools together a bunch of national supercomputing centers and makes their resources available by grant to anyone who applies and is awarded to them. So we had this ability or desire to run additional jobs and expand onto the resources provided by Exceed, but Galaxy traditionally needs a shared file system between the Galaxy server and the cluster nodes where jobs run, which is not possible with these compute resources that are provided by Exceed, since they're on the other side of the country a lot of the time. So the solution that we came up with for using these is Pulsar, the CERN VM file system, and then we deploy all this with Ansible. Next slide, please. So these components are, the first one's Pulsar. This is a service that runs over on the remote compute resource, and it stages the data between the Galaxy server, and it submits it to whatever cluster scheduling system is running over there. It manages those jobs, and then when it's finished, when a job is finished, it sends the results back to Galaxy. The CERN VM file system is a read-only file system, and it provides the reference data, the dependencies for Galaxy tools, and so forth over on remote systems. And then Ansible is a tool used for deployment, configuration management, and so forth. And this automates the process of actually provisioning cloud resources for the cases where we're using cloud instances. And then it deploys the software that I mentioned earlier, Pulsar and CVMFS. Next slide. So currently we have Galaxy running, as I mentioned, on some VMs at TAC in Texas. And then in order to use some of these Exceed resources, such as Jetstream, which is an OpenStack cloud divided between Indiana University and TAC, and then to use the Stampede's 2 supercomputer at TAC, and Bridges, which is a large shared memory system, which has been very useful for assembly tasks. We had to use Pulsar. And so you can see here sort of the connections that are made. So even within TAC itself, we have to stage some data around, because the file system where all of our data is stored is not necessarily available to resources such as Stampede 2 and Jetstream. All right, and I believe Simon's going to talk a bit about how Pulsar is used in Australia.
Yeah, thanks, Nate. The first thing I just want to explain to people, especially in Europe, is that Australia is quite large and doesn't have very many people living in it. And so, as Nate, sorry, Australia is around about the same size as continental US or most of Europe. A lot of the people living in Australia live on the eastern seaboard or over in Perth, and we do quite a lot of biological research in all sorts of different places in Australia, and it's very long distances between each of these places. Next slide, please. So, we have quite a long history of using Galaxy in Australia, and in around about 2014 we started these 2 public Galaxies in Australia, Galaxy Melbourne and Galaxy Queensland, but they were generally just used in their local area, and they had local support. The administration of these 2 servers was independent. They ran different tool sets, different reference data, and even though we talked to one another, it was very difficult to try and coordinate efforts. And then people in Sydney and Canberra who were outside of the places that the Galaxy servers were said, hey, we want to be able to use these things too. So we thought long and hard and thought maybe we should amalgamate these 2 Galaxy servers into one and use their resources to build a single Galaxy server. But because of the distances involved, we couldn't share disks and things. So anyway, in 2018, we amalgamated the 2 services and we produced Galaxy Australia. And it was predominantly built for Australian researchers and funded that way, but we've decided to make it available for everybody, and has been since it started. And very early on, we realized that we weren't going to be able to do this kind of scale by ourselves, and it would be a really good idea to start talking with other large public servers around the world. And so we formed relationships with usegalaxy.org, Nate, and usegalaxy.eu with Gianmauro and Fred and Marco and Björn, and really started talking about how we could share resources and learn from one another, and so usegalaxy.star was born. Galaxy Australia currently has about 8,300 users. It's growing pretty fast. It doubles every year. So, and we have about 1,000 users that are active each month, and we run between 80,000 and 110,000 jobs a month. Currently have about 1,200 tools installed. We try and run a common tool set, so very similar tools to what Europe and US run, but we do have some local variations. We also try and support about 250 reference data sets locally, and use via the CVMFS network, which is pretty global. Next slide, please. And the whole of this thing is running on an OpenStack cloud. A long time ago, the Australian government did something pretty unheard of and built a cloud network, and then gave it to the researchers of Australia and said, here, go and use this, and stop asking us for computers. But one of the really cool things was that they decided to make a federated cloud out of this. So it's one giant cloud with 8 nodes spread out around the country. It's all run by the Australian Research Data Commons. And Galaxy Australia was given access to some allocations, but they're all fairly small, and we needed some way of collecting all these nodes together to be able to make them work. And Pulsar is the ideal solution for this, for all the reasons that Nate talked about before. And by using Ansible, which is a lovely bit of software, and Terraform, which is a method of interacting with clouds and provisioning VMs in clouds very quickly, we found that we were able to set up a Pulsar node in an afternoon and have it accept jobs almost straight away. And so when the COVID-19 crisis hit, and Fred and Björn contacted us and said, hey, you're interested in being part of this global workflow analysis system? We said, yep, that'd be great. We're currently almost at capacity with our current thing, so we just started up a couple of new Pulsar nodes over in Perth, because we knew they had some spare capacity over there, and started running COVID jobs that day. So if you next slide. And so now Galaxy Australia is spread out to pretty much cover the entire continent, and we've also had lots of inquiries from lots of other people saying, hey, we can give you some compute resource if you'll let us use your thing as well. We said, well, you can use it now, but yes, we'd love to take the compute resource as well. And so as people offer us compute resource, we can easily add in Pulsar nodes to this thing and do more analysis. Thanks.
Okay, so usegalaxy.eu is the third element of the usegalaxy.star network, able to support a large user base. And through the usegalaxy server, we provide access to user to free compute and storage resources. We have more than 2,500 well-documented and maintained bioinformatics tools. We have a large set of reference genome, including most of the common plant genomes. We allow free registration to anyone to our server, and we have also a single sign-on system through the ELIXIR AI. To each user is granted about 250 gigabytes of space, but more can be requested easily with an online form. And at the moment, we have around 50,000 registered users, and we process more or less 400,000 jobs per month. usegalaxy.eu is founded by DEMBI. DEMBI is the German network for bioinformatics structure. Okay, next. So we have 3 main servers able to support a large user communities, but the Galaxy.star network is also growing with some use Galaxy server focused on regional aspect to support local community with locally interesting tools, and to facilitate to enable this kind of initiatives. We are working out to have what we call an open infrastructure. Next slide. An open infrastructure is a set of a public repository where all the details of our infrastructure are described, where one where we describe how we build our software stack, another one that where is described how we want to our VMs will be spun up in the cloud, others dedicated to tools and workflow that should be installed in a given instances, and also all the details dedicated to the static asset that should be available in our resource computing. And this kind of infrastructure is also using by the ELIXIR Belgium and the ELIXIR Estonia guys. Next slides. So the repositories are a public repository hosted on GitHub, and we have Jenkins and automation servers that take care to run all the continuous deployment and continuous testing process that are needed to be sure that the configuration that is hosted on the GitHub repository is correctly deployed on our infrastructure. Next slide. Okay, here I have a simple example. I added a new DNS entry in our infrastructure. I just started, I just created a new pull request on GitHub repository, and then Jenkins, triggered by the new pull request, asked Terraform to create an execution plan to have all this modification running on infrastructure. So Jenkins posted again on the pull request all the details of the execution plan that can be checked by me. And after everything was fine, I just merged the pull request, and then Jenkins asked Terraform to deploy the execution plan. So simply, so easy. Next slide. So with this open infrastructure in place, with all the resources provided by DEMBI that were appropriate for us, we started last year to ask ourselves about all these resources will scale in the future, and so we decided to work on what we call the Pulsar network, on a way to aggregate more computational resources from a different computer center across the Europe. And so we have resources from Italy, Belgium, Portugal, Spain, Norway, Czechia, Finland, UK, Freiburg, and altogether those resources are supporting the use Galaxy EU load. Next slide. Before to describe more in details the Pulsar network, I would like to highlight how Galaxy Europe is reaching the Pulsar site. Normally, the jobs from Galaxy Europe flow through the local scheduling system, through the workers that can be physical or cloud nodes. But instead, to reach the remote Pulsar site, Galaxy use a queue messaging system, a RabbitMQ server. So in this way, Galaxy don't need to reach directly the remote site. And this architecture, this configuration has two main advantages. The first one is that the remote Pulsar site doesn't need to have any open ports to the external network, because Galaxy doesn't need to reach directly the Pulsar site. And the second advantage is that, again, the Pulsar site doesn't need any public IP. And in this period is not a common resources to have. So Galaxy Framework offer different, very flexible option for create jobs endpoints, but in any case, we need a way to have a properly configured target system. And with this idea in mind, we have created a set of tools to have a ready-to-go Pulsar environment that can be easily deployed into a modern cloud infrastructure. Next slide. The first element of this set of tools is a machine image that we call it the virtual Galaxy compute nodes that have all the software needed to run Galaxy jobs. So we have the scheduling system, Pulsar, obviously, Docker, Singularity, Conda, and the 7VMF file system. Next. The other elements are a set of Terraform scripts that take care of the deployment of the VGCN image into the cloud resources. Next. In the end, we have an Ansible script that completed the Pulsar configuration and give us an easy mechanism to update it after. Next. The minimum requirements to have a prototype setup should be enough, should be composed but at least 2 virtual machines to have a central manager and an NFS server, and other resources to have a bunch of computational workers. But after that, the prototype setup is in place. It's just a matter to change some value on the Terraform script to upgrade, to update to a production a production configuration. Next slide. Okay, VGCN image allow us to have Pulsar with different flavors. We have regarding the possibility to resolve the software dependencies needed to run jobs. So we have what we call the Conda flavor. That means that Pulsar use Conda. Every time that Pulsar receives jobs for the first time, Conda creates the virtual environment needed to run that job. Otherwise, we can have also a container flavor that instead use Docker Singularity engine to run containers for the tool execution. Or we can have also a Pulsar using Docker, but this time to run containers, leveraging any NVIDIA GPU devices that are available in the work node. Next slide. Okay, so now we have remote computational sites. How we can distribute the jobs to that remote site. Our ideas here. Use Galaxy-EU as several subdomains dedicated to some specific topics like chemoinformatics, proteomics, or machine learning. So we can imagine that each subdomain can have a specific Pulsar site taking care of the jobs of that subdomain. Or we can distribute, we can imagine that each tools can, we can assign to each tool a Pulsar site, looking also at the input, at the sites of the input data to avoid to send through the network large data set. Or we can imagine that a user from a specific country can have all its jobs redirected to the Pulsar from the same country. Or we can have a for the training activities dedicated Pulsar machine. But any idea welcome. If you have any, let us know. Next slide. Waiting for your ideas, I'm showing you what we are doing now. Here we have the user preferences panel from Use Galaxy-EU, where we have added a new menu called Use Distributed Compute Resources, where a user can decide to skip the default configuration and have all his jobs redirected to a specific remote Pulsar site. But this tools is mostly dedicated to developers or system administrators that want to test tools against a specific Pulsar site. Next slide. Instead here, we have an example of tools from one of the tools from Use Galaxy-EU that is normally redirected to a Pulsar site. It is Circos. Circos is software for visualizing data in circular layouts, and you have on the right some nice example. And for several months, if you have run any circus jobs through Use Galaxy U, your job has been processed by the data center from Técnico Lisboa in Portugal. Next slide. And instead here, I have an example of one of our largest Pulsar installation. We are using, in this case, it's kind of a hybrid Pulsar because we are using the CPUs and GPUs. We are using resources from two remote sites, from the Diamond Cloud from UK. Diamond, it's the national synchrotron facilities in UK, and resources from DEMBI in Germany. So in Diamond, we have 10,000 CPUs and 20 GPUs, and instead in DEMBI, we have 20 GPUs. And so we put together all these resources using Pulsar to support the Bioinformatics COVID activities that has been described by Simon and team 2 webinars ago. And in the last 3 months, we have distributed through this system 30,000 GPUs jobs. As you can see in the stats, in the graph in the center, on the left, we have our normal baseline of jobs that are around 500 jobs, and you can recognize easily the signature of Bioinformatics workflows running, because suddenly there is a peak that reach 5,000 jobs and stay there for hours. Next slide. Okay, here another piece of our open infrastructure, the Grafana dashboard, where we are collecting several stats from all our infrastructure. In particular, here we have an overview of the compute time from all our Pulsar sites. As you can see, some of them are running really hard, someone else less, but everyone are working together to support the Use Galaxy that you load. Next slide. And okay, I think this is now Marco turn.
Yes, thank you. So we put here also the Pulsar network documentation. Basically, we collected a step-by-step tutorial to deploy your endpoint Pulsar endpoint. And what I want to highlight here is that everything has been automated using Terraform and Ansible recipes, but still, of course, you need to interact with the Use Galaxy.eu developers to connect your Pulsar node and start to run jobs. To do that, you will need a couple of pull requests on their GitHub repository. And then after no more than 1 working day, you should be able to run jobs on your Pulsar endpoint. Next slide. Thank you. So here we are going to talk about Laniakea, next slide, which is a Galaxy cloud instance provider. So you can deploy your own Galaxy instance using on a cloud infrastructure using a user-friendly dashboard. Next slide. There are still some scenarios where a private Galaxy instance is still needed, for example, for training activities, tool developments, but also some data privacy concerns. Next slide. For these reasons, relying on the Italian Galaxy Italian cloud infrastructure and of course Galaxy project tools, we created this software, which basically has a dashboard, which is the entry point of the services of the service to create your Galaxy instance. We have of course authentication and authorization system. We then have the orchestration layer that is able to deploy Galaxy, deploy the storage and the tools, install Galaxy and install the tools, and of course the reference data with the SerVM file system. Next slide. This is the dashboard of the Laniakea service. So each tile provides a service, a way to deploy Galaxy. We have virtual machines, but of course we can deploy Docker container. Next slide. This is the panel for the configuration of Galaxy. You can customize it in terms of virtual CPU, RAM, and storage. And of course, you can provide your SSH key to log into the virtual machine if you need it. And you have a Galaxy tab where you can choose the Galaxy version and of course the flavor that we will see later. Next slide. This is the Galaxy Instance Management view. So we will have at the end of the deployment of a public IP address to run your Galaxy, and of course you can then delete it if you don't need it. And for other option of Laniakea, I would address you to the Laniakea website and the documentation. Next slide. Okay, so let me just highlight two features. The first one is the storage encryption. So you can encrypt on demand all the user data storage of our Galaxy instance, and this is completely automated. The second one is the possibility to deploy Galaxy instances with the already available presets using virtual machine or Docker containers that is on your choice. There are already available presets, but I want just to highlight that of course we are providing also the COVID-19 flavor through a Docker container, which is the same of the Galaxy project Docker. Next slide. Okay, so we talk about the global infrastructure, how to deploy your own Galaxy instance, and this is how to customize your private instance. If you want to install tools and workflow for COVID-19 analysis, there is a nice tool that is Ephemeris, which is a Python library allowing you with in few steps to install all the COVID-19 tools and workflow. We leave you here the training material for Ephemeris and the COVID-19 user's guide. And this is something that the use Galaxy.star and Laniakea are using daily to maintain their tool sets. Next slide. And finally, of course, if you don't have access to any Galaxy instance, you can still run on your own the Galaxy Docker with the COVID tools already available, and of course also the reference dataset through the CernVM file system. And also in this case, we leave you the documentation and the training to deploy it. I think it is to Björn now.
Yeah, so I guess now it's time to wrap up. You have seen 5 webinars in this series, and this one is, has introduced you to more or less the concept, the infrastructure behind all the scientific work that you have seen in the 4 webinars before. And if you have questions, please, ask them in the chat, let us know. With that, I would like to thank, next slide, please, all the infrastructure providers and all our funding agencies worldwide that make that actually happen. Especially, all the compute centers that have provided resources in all these Pulsar endpoints that we have mentioned. Without that, it would not be possible to scale actually and to run these workflows that have many thousands of jobs in parallel on many thousands of data sets that we are seeing. So we need this infrastructure and we need the scalability, and without that, it wouldn't be possible. Next slide, please. Especially, I would like to thank all speakers that you have seen in the last 5 seminars now, and special thanks to Premusel and Jennifer for organizing this webinar series, also for the technical help in setting up this webinar. So thanks a lot. That was really cool and awesome. And the next slide, please. So the last slide. So James Taylor founded or co-founded Galaxy back in 2005. and he suddenly passed away a month ago. And what he and his team developed is more or less a foundation which we are now building upon with a worldwide network of administrators, of scientists, of developers that are working together for one big goal, open reproducible science that is accessible for everyone. And yeah, we would like to thank James for all his work that he's done. And the Galaxy project has created a James Taylor Foundation called JTAG that will help in sponsoring scientists and sponsoring people to take part on conferences, to learn, to get knowledge, and to do greater science. So please look at it and keep in mind that this network, as it is today, is largely also designed by James Taylor. So thanks a lot, James.